Step 1, generating hypotheses. So now that you know the overall objective of this activity, I want you to start at the very beginning with your lab group and work to generate and write down a null hypothesis and an alternative hypothesis pertaining to whether or not you hypothesize that this population of snails is undergoing evolution. And before you start the calculations procedure, your lab group should create a data table, actually multiple data tables, in which to record your data, such as that what you see on the screen here. And I recommend writing down your tables in this order because each table builds from the previous. We were given the observed number of organisms, and you can use that number, those numbers, by applying them, using them in those Hardy-Weinberg equations to calculate your allele frequencies. And then you can use those allele frequencies to calculate your expected genotypic frequencies. And then you can use that information to then finally calculate your expected number of organisms. And then that final step will be to compare those expected number of organisms, if the population was at equilibrium, against your observed number of organisms to see if they are statistically significantly different or not. Remembering if they are statistically significantly different from one another, that means that the population is likely not at equilibrium, because if what is seen in reality, our observed numbers, are different from the numbers that fall under Hardy-Weinberg equilibrium, if they're different from that significantly, then that means our population is probably not at equilibrium, right? Which means our population is likely evolving. And of course, the inverse is true. If they are not statistically different from one another, meaning they are similar enough that we can mathematically say they're actually pretty close to one another, that means that they probably are not undergoing evolution. The population that you're looking at is probably at equilibrium because it's pretty darn similar to those expected numbers that we would expect to see if the population were at equilibrium. Make sense? Okay.